Today we're going to move on to the next section, which involves factoring using distributive property. But first, I just want to review distributive property. Let's say that I had 3x times 2x minus 5, and I wanted to multiply through with distributive property. Well, 3x times 2x is 6x squared minus 3x times 5 is 15x. What's going to happen today is we're going to be given this expression and we're going to need to, it's called factor it. That means go backwards into this. When you see this word factoring, you need to get used to it. Factoring, if you remember, is taking a number like 15 and breaking it down into 3 times 5. That's factoring. Alright, multiplying two things together to get this. So we're going to be given an expression like this, and we're going to go backwards into this. And it's not that bad. Let's get started. So let's say that you are asked to factor the polynomial. And let's say that we have 14x minus 21y. Well, all we want to do is we want to work backwards. Okay, we're not solving an equation, we're just factoring it. So you may just want to think of an arrow. But I want a set of parentheses. And what I want to do is pull out of each of these the greatest common factor, or the biggest thing that will go into both 14x and 21y. I think it's pretty obvious that the biggest thing that will go into both 14 and 21 is 7. There are no common variables in both, so I cannot pull out a variable. Now what you think is 7 times what will make 14x? Well, that's 2x. Minus 7 times what will make 21y? That's 3y. And guess what? We have factored that polynomial. Let's do another one. All we're doing is factoring. We're going backwards. Let's say that I had 32x squared minus 40x. Now on this one I'm going to work down because I don't want you thinking these are equations. So we need a set of parentheses. I've got a minus there. Let's go ahead and put the minus in. And I want to think, what is the greatest common factor of 32x squared and 40x? Well, I think you can tell that the greatest common number factor is 8. Okay, so I'm going to pull out an 8. Now how about x squared and x? Well, x squared is x times x, and x is just an x, so the one that's common to both is an x. So we pull out an x, and then I think 8x times what will make 32x squared? Well, that's 4x. And then 8x times what makes 40x? That's just 5. And so there's our answer. Now there's another type of factoring that's called factoring by grouping. And you use factoring by grouping when there are 4 terms. So let's say that I have 6ax plus 3ay plus 2bx plus by. Notice that I have 1, 2, 3, 4 terms. What we're going to do is we're going to split this thing in half and we're going to factor each of these halves the way that we just did. So let's look at 6ax plus 3ay. I'm going to do backwards distributive property. It looks to me like there is a 3a in both of these. Yes. So then 3a times what makes 6ax? That's 2x. Plus 3a times what makes 3ay? That's a y. Now let's do it with these two over here. Now let me give you a huge clue. Alright, when these factor by grouping problems are done correctly, this thing should be the same thing as this thing. Let's see if we can make that happen. Let's put a 2x plus y right here. So what can I pull out of both of these? It looks to me, when I look at these two terms, the only thing that's common to both is a b. So I can pull out a b. And let's check it. B times 2x is 2bx. B times y is by, and that works. Now, we're almost done. These two things that are common to both, this 2x plus y and this 2x plus y, we're going to do distributive property again and pull that out. 2x plus y times, what is it times? Well, it's times what's left, 3a plus b. These problems are pretty easy if you get this first one factored correctly and you remember that this thing right here, that this should always be duplicated here. Let's do another one of those. Let's say that I had 6y squared minus 4y plus 3y minus 2. Once again, we're going to split this thing in half. And I'm going to start with this one. What can I pull out of both of these? I can pull out a 2y, which leaves me with 2y times what makes 6y squared. That's 3y minus 2. So guess what? There's going to be a 3y minus 2 over here. This is a plus, so this is a plus. And then this is kind of odd. There's a 3y minus 2, and that's what I want. What can I factor out? Well, a 1. Isn't 1 times 3y 3y? And 1 times 2 is 2? See, we need a number here so that I can finish the problem. So finishing the problem is now easy. I pull out what is common to both, 3y minus 2, and it's going to be times whatever is left, 2y plus 1. Alright. The last thing that you're going to do in this section is you're going to solve some equations using the properties that we just learned. So let's say that I had to solve 9x squared plus x equals 0. So first thing we need to do is factor it the way that we just learned. What's common to both of these? An x. So x times 9x plus 1, yes, that checks. X times 9x is 9x squared. X times 1 is x. But now we are solving an equation. So I keep this equal to 0. Well, there's a little property called the zero product property that allows me to do this. Split this into two separate equations. 9x plus 1 equals 0, and whatever this thing is equals 0. And I solve them separately. Well, guess what? This one's already solved. And this one, I just do my algebra. 9x equals negative 1. Divide both sides by 9. So x equals negative 1/9. And guess what? We have two solutions. That's okay. Let's do another one of those. Let's say that we had 10x squared equals negative 5x. Well, this one's a little bit different because it's not set equal to 0. We want it to be set equal to 0, so I can use the zero product property. So I need to add 5x first to both sides. That way this side is equal to 0. Over here I have 10x squared plus 5x, and I do backwards distributive property again. What is common to both of these? A 5x. So I pull out a 5x. 5x times what makes 10x squared? That's 2x. 5x times what makes 5x? That's a 1. And now I can use the zero product property and split this into two problems. I can set 2x plus 1 equal to 0, and I can set 5x equal to 0 and solve them both. This one's easy. Divide both sides by 5, x equals 0. Over here I do my basic algebra to solve it, and I get negative 1/2. So once again I have two answers. One last little thing that you're going to see. Remember to use your notes, or you can re-watch this video when you're doing the assignment. What if they give you this? X minus 5 times x plus 3 equals 0, and they tell you to solve it. This is maybe the easiest problem of the day, because this problem is already factored into something times something. So guess what? I can split this up right now and solve both of these using the zero product property. Really easy to finish solving these. I get x equals 5, and I get x equals negative 3. Now, I just want you to notice that the setup of this problem is different than the setup of like this problem. This one says 9x squared plus x. I can't split this up until I write it as a product like this. And this one, I cannot set this side equal to this side. I need to get it equal to 0, and then I need to factor it before I split it up. This one was already factored. That's why we can split it up and go ahead and solve it. And I'm going to stop the video there for today.